In this video, I'm going to go through the rest of the note sheet from yesterday. Yesterday's note sheet was all about dilating functions. So we multiplied functions together, we simplified functions, we wrote them in standard form, and today we're going to focus on finding the zeros of those functions. So if I look at problem number 1, up here we had f of x, and we took it all the way down to f of x was in now standard form. Now this is going to be a little bit weird because if I want to find the zeros of the function, I actually don't want to work in standard form. I want to work with the very first step of this equation that I wrote. And so I'm going to rewrite that down here. So f of x is equal to, I have one factor that's 2x minus 1. I have another factor that's x plus 2, and I have a third factor that's negative 3x minus 1. When I want to find the zeros, now zeros have multiple names in math when we talk about them. They are sometimes referred to as zeros. There's roots, there's x-intercepts, and there's solutions. And if that's what I want to find, I actually want this problem to be in factored form, which it is right here, because what I'm going to do is set each factor equal to 0. All right, so my first factor here is 2x minus 1. So I'm going to make a little equation. I'm apparently also going to make that pop up, but I don't know what I just did. I think I just took a picture. Well, isn't that special? All right, so I'm going to take this first expression, this first factor, 2x minus 1, and set it equal to 0. Separately, I am going to take x plus 2, make a little equation with it, right? That's our next factor, x plus 2, set it equal to 0. And the last one here is negative 3x minus 1. And I am going to take that factor, set it equal to 0, and solve. Now, this is just like solve by factoring with quadratics. The difference is when you're dealing with quadratics, at most you're going to have 2 factors with those. Obviously, with these higher degree functions, you can have more than 2. So as long as it's in factored form, you can set each of these factors equal to 0. All right, let's go ahead and start solving these. So this first one here, I'm going to add 1 to both sides. So 2x is equal to 1. Divide both sides by 2. X is equal to 1/2. Little middle factor here, x plus 2. I'm going to subtract 2 from both sides. So x is equal to negative 2. And last but not least, I have negative 3x minus 1. So I'm going to add 1. So negative 3x is equal to 1. Divide by negative 3. Let me make that negative there. And x is equal to negative 1/3. Now, I'm going to be completely lazy and just draw a really big box around all those answers. So we had 3 factors here. Each one of the factors got set equal to 0. We solved each of the little miniature equations, and in this case, we have 3 answers for x. So those are the zeros, all right? So I'm going to slide over to number 2, and I want to determine the zeros of g of x, all right? Again, this function that I boxed up yesterday or boxed up in the last video, this g of x is great. It is in standard form, and that's what we were asked for. But to find the zeros, I'm going back to this original piece where I just wrote each of the factors as a multiplication problem, all right? So g of x is equal to, the first factor is x plus 3. I have 2x minus 1, and then I have negative 2x plus 2. So I no longer care about that top part. I just want to look at this piece, all right? So I'm going to take my first factor of x plus 3, set it equal to 0. I'm going to take my next factor, 2x minus 1, set it equal to 0. And my last factor here is negative 2x plus 2. So I'm going to make a little miniature equation here, negative 2x plus 2 equals 0. So I have these 3 little equations to solve, all right? So subtract 3 from both sides. X is equal to negative 3. And if you want to, you can just put a box around that one right now. In the middle here, we've got to add 1 to both sides. So 2x equals 1. Divide both sides by 2. X equals 1/2. please leave your answers in fractions, no decimals, unless the directions explicitly say decimal, which they're probably not going to. I'm going to subtract 2 from both sides here. So negative 2x is equal to negative 2. Divide both sides by negative 2, and I'm going to get x is equal to 1. Okay. Let me double check those two factors. Yep, we're good. All right. So again, we have 3 answers here. For each one of our factors gave us an answer. And so now we know our zeros. All right. So now what happens if we're looking at a graph? Well, your zeros in the graph are going to be your x-intercepts. So the x-intercept here of the function that we drew, if you go back to what we had here, is just this point right here. It's just the point through the origin. So our 0 here is going to be the point 0, 0. All right. You could write this as x equals 0 as well if it's just talking about the x value of the function. All right, so that's that one, only 1, 0, because there's only one x-intercept. Okay, now if we take a look at problem number 4, right, we had 2 x-intercepts in this problem. We went through the x-axis here, and we went through the x-axis here. So both of these account for zeros. So at the bottom here, I'm going to put a little note, zeros. All right, so I have 2 pairs here, 0, 0, which is the origin, and I have the point, what is this, negative 3, 0. So that would be x is equal to 0 and x is equal to negative 3. Okay, so if you have the graph and you're asked to identify the zeros, you can either give me ordered pairs or what x is equal to. Okay. All right, problem number 5 and 6, we again did part A yesterday. So part A, we dilated by the function by, in this case, x with these other 2 pieces of f of x. It says identify the zeros of the function h of x. Okay, well, remember I talked about yesterday, we didn't have to multiply this out because it didn't say to, which means it's already in factored form for us. So take each factor, set it equal to 0. So x is a factor, it's equal to 0. X minus 1 is a factor, it's equal to 0. And 2x minus 3 is a factor, so it's equal to 0. Now, this first one, x equals 0, it is already solved for us, so we're good. I'm going to add 1 to this middle little equation here. X is equal to 1. And now I'm going to do a couple steps here. So I'm going to add 3. So 2x equals 3, divide by 2. And x equals 3 over 2. Leave your answers as fractions, please. Okay. So we had 3 factors. Factor of x minus 1, and a factor of 2x minus 3. Since each one of those factors had a variable x in it, we have 3 different zeros for our function. All right, last problem here for this video. I'm going to slide over to problem number 6. We have a of x, which has factors of 2x, 3x minus 1, and x plus 2. We want to identify our zeros. So we're going to take each factor. In this case, I'm going to do 2x equals 0. And do 3x minus 1 is equal to 0. And x plus 2 is equal to 0. So this first one here, I'm going to divide both sides by 2. And we're going to get x is equal to, well, 0 divided by 2 is just 0. 3x minus 1, I'm going to add 1 to both sides. So 3x equals 1, divide everything by 3. X is equal to 1/3. And to get x by itself when it's being added to 2, I'm going to go ahead and subtract 2 from both sides. So x is equal to negative 2. All right. So that concludes this particular video in terms of finding all the zeros. I will make a separate video that will go through the review problems so you understand how to do those if you are struggling with those at all. And if you are struggling, please feel free to reach out, send me an email, join the Zoom links, do what you need to do to get some help with these problems.